Hello friends, so in today's question, the system shown in figure is in equilibrium. Find the acceleration of the blocks A, B and C of all of equal mass m at the instant when, assuming the springs to be ideal. First condition, spring between ceiling and A is cut. The string between A and B is cut. And the last case is spring between B and C is cut. And in the respective three cases, we are also going to find out the tensions. Okay. So these are the two springs having the spring constant K, and let us say we call this a spring S1 and this spring S2. Okay. And we say that the displacement of this S1 is x1 and for this S2 is x2. Okay, you can see that let the two springs are S1, which is between block B and block C, and x1 is the extension of S1, and we say that S2 is between block A and ceiling, and x2 is the extension of S2. So these are the basic things. So before the string is cut, everything is in equilibrium. Okay, as it is written. So you can say that before any string or spring is cut, the system is in equilibrium. So under this condition for block C, okay, so under this condition block C, so if we draw the body diagram for block C, you can clearly see that this is block C. Mass is given as m, so there will be mg in the downward direction, and there is a spring constant K, and x1, that is Fs, will be acting in the upward direction. So from here we can write that Kx1 will be equal to mg, or we can say that x1 is equal to mg divided by k. Let us call this equation number 1. Now in the first case, it is given the spring between ceiling and A is cut. Okay, so we can say that in the first part, spring between ceiling and block A is cut. So under this condition, you can say that this will be our block A connected to block B, and so we can treat this as one single system. Okay, let us suppose as there will be no slack between the string, so we can say the combined it is moving with the acceleration of A, and in the downward direction there will be 2 mg, as mass of this is m and this is also m, and also in the downward direction there will be k x1 because of the spring, because all of a sudden nothing is going to change. So normally this will be connected in this way to the spring, and here we will block C. So we can say that for no slack in the string, no slack in the string, A and B will move with same acceleration, A and B will move with same acceleration, and let us suppose that acceleration is given as A. So we can write the equation as k into x1 plus twice mg will be giving us 2m into A, and we already know the value of x1 from equation 1. So from equation 1, x1 is equal to mg divided by k. So substituting here, we can get this as k into mg by k plus 2mg is equal to 2ma. So m cancels out entirely and k goes with k. So from here we can say that acceleration A will be equal to, this will be 3 mg, or m cancelled, we can say 3g divided by 2. Okay. Now from here we can say that acceleration of A, block A, will be equal to acceleration of block B, and which will be equal to A, and this both will be 3g by 2. Now for block B, this is block B traveling in downward direction with the acceleration A, and there will be force mg in the downward direction, and there will be, because of spring, that will be kx1, and upward direction, let us suppose there is a tension T because of the string. So we can write the equation as mg plus kx1 minus T is equal to ma, and we also know the value of x1, so we substitute here, we can write mg plus k. x1 we have mg divided by k minus t is equal to m, and we also know the value of acceleration, that is 3g by 2. So k cancel out the k, m goes entirely from, sorry, my mistake. So we can write this as mg plus k into mg by k minus t is equal to m 3g by 2. So k cancel out with k. From here we can say that this will be 2 mg. So we can say t is equal to 2 mg minus 3 mg by 2, and we can write this as 4 mg minus 3 mg by 2. So tension will be coming as equal to mg by 2. Tension will be equal to mg by 2. Next we have for C, okay, for block C, block C, this is block C, and we have upward direction k x1 and the downward direction there will be mg, and let us suppose the acceleration is ac. So we can write this as mg minus kx1 is equal to mac, okay, and we put the value of x1. We can write this as mg minus k into mg by k is equal to mac. Now this k cancel out with k, entirely mass goes, this will be g minus g is equal to ac. So from here we can say that acceleration of ac will be equal to 0. So this is the acceleration of block C. Acceleration of block C. Now in the second part it is given the string between A and B is cut. The string between A and B is cut. Okay, so from here we can clearly see that the string between A and B is cut. Okay, now before the string is cut, okay, so let us consider a situation before the string is cut and after the string is cut. Okay, so before string is cut, we have system is in equilibrium. Okay, system is in equilibrium. So we can write that our combined system of A plus B, we have the upper is given as x2, so this will have kx2. The downward direction we are going to have 2 mg, and there will be also, because of the spring x1, we are going to have kx1. So we can write the equation as 2 mg plus kx1 is equal to kx2. Putting the value of x1 from equation first. Okay. So from equation 1, using x1 is equal to mg by k. So we get this as 2mg plus k into x1 is mg by k is equal to k times x2. So k cancels out with k, and we have here as 3mg. We can write this as 3mg is equal to kx2. From here we can say that x2 is equal to 3mg divided by k. Okay. We have here 3mg divided by k. Now, after the cut, of string between A and B. Okay. So we can consider the block A. So block A, this is A. In upward direction we have a kx2, and in the downward direction we have mg. As the string is cut, the tension will be 0. Okay, after the cut we can say the tension will be equal to 0, and we say that it is moving in direction in downward with AA. So from this equation we can say that mg minus kx2 will be equal to m acceleration of A, and we have this equation. Let us call this equation number as, I think it will be 2. Yeah, equation 2. So we can say that from equation 2, x2 is equal to 3mg divided by k. Okay, this is g. 3mg divided by k. So substituting this value, we get this as mg minus k into 3mg divided by k is equal to mass into acceleration of A. Now k cancels with k and m cancel out entirely. So from here we can say that acceleration of A will be equal to minus of, this will be 2g. So from here we can write that acceleration of block A, which is equal to AA, is equal to 2g, and it is in upward direction. Upward. Now, okay, this we did for block A or block A. Now we consider for block B. For block B, so this is block B, and in the downward direction we are going to have kx1 and we are going to have mg, and let us suppose it is moving in downward direction for acceleration ab. So from here we can say that mg plus kx1 is equal to ma b, and we already know the value of x1, so you can say that from equation 1 x1 is equal to x1 was equal to mg by k. This was mg divided by k. So we put the value mg by k we can say mg plus k into mg by k is equal to m a b. Now k cancel out and m cancel out entirely, so from here we can write that acceleration of b will be equal to twice g. So we have acceleration of block B which is equal to AB and which is equal to 2g in downward direction. Okay. Now our next is for block C. For block C, okay. So we can draw the block C like this. This is our C. We are going to have mg in the downward direction. Let us say the acceleration is given as AC, and we have that is k, and the spring constant of this is given as x1. This will be x1. So we can write the equation as mg minus kx1 is equal to m into AC. We have the value of x1. Okay, so we can say that from equation 1 x1 is equal to mg divided by k. We put the value, so we can that mg minus k into mg divided by k is equal to m into AC. K cancel out, m cancel out, so we can say that AC come equal to 0. Okay. So it means acceleration of block C which is equal to AC is equal to 0. And in the third part we are going to find out the spring between B and C is cut. The spring between B and C is cut. So we have third part, spring between B and C is cut. B and C is cut. So in this case also we can say that if the spring between B and C is cut, so A plus B, so we are going to have 2mg in the downward direction, and in the upward direction we are going to have k and spring constant is given as x2. Okay, and let us suppose it is moving in downward direction with acceleration capital A, which will be acceleration of A and acceleration of B, same value. So from here we can see that 2mg minus kx2 is equal to 2m capital A, and we already found out the value of x2, that is 3mg. Okay, that is equation number 2. You can see that from equation 2, x2 is equal to 3mg divided by k. So we put the value, get 2mg minus k into 3mg divided by k is equal to 2ma. We have k cancel out, mass also cancels out, and we have acceleration A is equal to, we have this as minus g and divided by 2. Okay, minus g divided by 2. So we can say that acceleration of let me write it here, acceleration coming as minus g by 2. So we can say that acceleration of block A and B, which is equal to A. So we can write acceleration of A is equal to acceleration of B is equal to g by 2, and this will be happening in upward direction. Upward. Okay. And next is our this was for block A and B. Let me write it here for block A and B. For block A and B. Okay. Next is for block C. For block C. So for block C, this is C, there will be mg in downward direction, and we have acceleration AC in the downward direction. And when, one second, spring between B and C is cut. Spring between B and C is cut. Yeah, that's correct. So we can say that we have mg is equal to MAC. So M and M cancel out. So we get AC is equal to G. So from here we can say that acceleration of block C is equal to AC, and that is equal to G. That is acceleration due to gravity. And last is our for block for finding of the tension T. Okay, so we are going to find out what will be the value of tension T for tension T considering block B. So for block B, we see our block B. So in the upward direction we are going to have tension T, and in the downward direction there will be a mass mg, and there will be spring constant of x1, so this will be kx1, and we already said that it is going to move in downward direction with the acceleration ab. So based on this we can write the equation, which can be written as that kx1 plus mg minus t is equal to m ab. So we already know value of x1. X1 is from equation 1. Okay. So we can say that from equation 1, x1 is equal to mg divided by k. So we put the value, get k into mg divided by k plus mg minus t, and m into ab, acceleration of, we already found out that the acceleration is here, that is g by 2. Okay. So we can put ab, that is g by 2. So k cancels out, so we get mg, that is 2mg minus t is equal to mg divided by 2. So we can further solve this. This will be coming as t is equal to 2mg minus mg by 2, or we can say that tension T will be coming as 4, and this will be coming as 3 mg by 2. So this is the tension for the third case. So this completes the question. So in detail, in the short, we can write that the important consideration that is kept in mind, that for the spring there is no sudden change. Okay. So as soon as the spring is the tension is cut, a spring is cut, the force remains momentarily the same. So this concept is used mostly in every example whenever there is a spring involved in the process. Thank you.